okay? And yeah, and then you are going to have this project in your account basically forever. So if, in case that you want to revisit it next week, next month, whatever, you are going to be able to do so. All right. Then let me go back to my project. So once your project is fully loaded, you should be able to see here the notebook for today's special open class. Okay. Okay, how do I connect to the project? You just press, start or run. I don't remember which is the button. Okay, then for today's class, we are going to be working with BotBox, okay? If you are not new to open classes and you have been attending to the last open classes, probably you are already familiar with this BotBox because we have been already using it for several open classes and even connecting to the real setup, which you can see an image here, okay? But basically, the BotBox is a new product that we have created and is a lab in a box, which it's perfect to teach robotics, okay? So this BotBox, you can see the contents here. It provides 3 robots that you can mount. The environment, which is based on a warehouse with all the materials needed to mount it. It contains also grippers for the robots, cubes that you can use for simulating pick and place tasks. It contains the floor for your environment, for the map. It contains already created ROS projects, like this project here, but several ROS projects that you can use for teaching things such as ROS to basics, navigation, perception, and all the core topics related to ROS. And many, many more things, okay? It contains already prepared simulation, so that you are going to have the simulated environment and also the real environment to teach both in simulation and in the real environment. And I have let here the link in case that you want to get more details. You can come here to the BotBox page and yeah, give it a look, get more details. It's super interesting and it's especially a good tool for teaching robotics, okay? Because basically it's going to provide you everything that you need to start teaching, both theoretical aspects. You are going to be able to do practice with real robots, which is something super important, and in many cases it's not so easy to have access to these real robots, to be able to practice also with real world projects. So with this box, you are going to have everything that you need in order to start teaching robotics. If you are at a campus, at a school, whatever. Sorry, my throat is a bit dry. So yeah, give it a look and you are going to be able to order it also directly here from this page. And now, so that you get to know a little bit more about this BotBox warehouse lab, we are going to start using it ourselves, all right? So what we are going to do for this class? Well, the mission for this class is very clear. We are going to, sorry, we are going to create a ROS2 node, a ROS2 program that allows us to take pictures of the environment using our robot, our BotBox in this case. Yeah. So BotBox are provided with a LiDAR, are provided with a camera, with encoders, with different sensors that are going to obviously provide many of the basic robotics features. Okay. So in this case, we are going to be using the camera. Okay, because we want to create a program that allows us to take pictures using our mobile robot. Yeah, why? Well, for instance, this can be very interesting for a robot which is patrolling a warehouse environment, and then it takes pictures of specific points of interest so that we can make sure that everything is correct in our warehouse. Yeah? This could be an interesting behavior, and this is what we are going to be doing today, okay? We are going to create the program to take the pictures using the camera of our BoxBot, all right? Then, we are going to start by checking this in a simulated environment. Here, we are going to be using a simplified environment, okay? This is not the final one. The final one that you are going to get with the BotBox, it's much cooler. You can actually see it here, okay? As you can see, this is much more cool, but for this class, we are going to keep it simple, and we are going to use a simplified version of this warehouse environment, okay? Then in order to start the simulation, all you have to do is to execute this command that you can find here in the notebook, all right? So, in order to execute this command, you need to open a terminal, okay? How to do this? Very easy. You have to come here in your ROSJECT to the bottom menu, and here you're going to find several icons in the right side, bottom right side. The very first one that you're going to find here is the web shell icon, okay? So if you click here, this is going to open a new terminal, as you can see. Yeah? Let me show it again. So you come here to the bottom menu, you are going to find this icon, which is named as web shell. And if you click here, this is going to open for you a new terminal, okay? And in the terminal, you can just write typical Linux commands. This is a regular Linux shell, okay? Nothing special about it. Then what I suggest you do is that you copy the command directly here from the notebook, and then you come to the terminal, to the shell, and paste the command, and then you just execute it, okay? And then basically you have to wait a few seconds. You are going to see all these log messages being printed here into the terminal, and after a few seconds you should see the Gazebo window automatically pop up. There you go, okay? Now here, we can see that the simulation has loaded, but actually, in many cases, actually this is one of these cases, yeah, Gazebo has not launched properly. Okay, this is an error with this specific simulation. In Gazebo, sometimes it happens, okay? So, in case that your simulation doesn't launch properly, like it is my case, okay, don't worry, okay? This is normal. It is very easy to work it around. You have actually the steps indicated here in a note, right below here, the simulation section. So, in case that your simulation doesn't launch properly, all you have to do is to execute this command here, okay? This kill_gz.sh. This is a script that I have prepared for you so that you can execute it and automatically kill all the Gazebo processes, yeah? Let me show you how to do it. So, you come here to the terminal where you launched the simulation, you press Ctrl+C to stop the current running program, okay? Just wait, and then once it stops, you paste this command here, okay? It is, again, you can directly copy it and paste it from the notebook, okay? You execute this script here to make sure that you are killing all the Gazebo processes, and then you just relaunch again the previous command to launch the simulation. Yes, same command as before. You just execute this command again, and the second time that you start the simulation, it should start already properly, okay? For some of you, it's going to start properly the first time. For some of you, not, and you're going to need to do this. And now, as you can see, the simulation is launched properly. We can also see the values here, real-time factor, you can see it here, and you are going to be able to move the camera around the Gazebo client, okay? This tells me basically that now the simulation has launched properly. Yeah? So far so good. Is everybody following? Let me have a quick look at the chat here to see how you guys are doing. Yes, yes, good, yes, yes, okay, yes. All right, so apparently everybody is following properly. So everybody has the simulation running as I have. Yes. The bar below isn't showing for me. Okay, that's strange, Adele. Try refreshing your screen or something. I don't know. If you refer to this bar, it should be showing for everybody. Okay, or maybe, yeah. Try refreshing your page, maybe. I don't know what else it could be. Okay, then let's continue. All right, so now that we have the simulation running, the very first thing that I want to do is to visualize the camera data, okay? So the camera data in the simulation is being published into a topic, yeah? So let's do one thing now. We are going to open a second terminal, okay? A second shell. We are going to leave this one here running because we need the simulation running. And then you can press here in the plus icon that it is up here in order to create a second terminal, okay? There we go. And for instance, in this second terminal, we can run the ROS2 topic list command. Let me repeat it. There we go, ROS2 topic list, and then here we can see all the topics available. For instance, we can see some topics up here which are related to the camera, right? We can also see the very usual command bell topic, yeah, which is used to teleoperate, to send velocities to the robot, yeah. But in this case, the topic that we are interested in is this camera /image row, yeah. This is the topic where my camera is publishing the images that it is capturing, okay? Then how can we check out these images? Well, in this case here, you have a command that you can execute, yeah, which is going to launch RVs with a pre-configured file that I have prepared for you here, yeah? So let's copy this command here and paste it into this terminal. There we go. We execute it, and then after a few seconds, we should see here the RVs window popping up. Okay, let me make it bigger so that we can see. And then here, let's uncheck and check again this camera display. There we go. Okay. So this is the camera and the images that the robot is capturing right now, okay? If we go back to the simulation, we can see that basically it's showing us the front area of the robot, right? Yeah? Then for instance, let's try something else, okay? Now that we can visualize the camera in real time here using RVs2, let's open a third terminal. Okay. And here we are going to execute the very famous teleop twist command. Okay, so it is ROS to run teleop twist keyboard and teleop twist keyboard. Okay, I think this one I didn't add it to the notebook. Okay, so let me. Yeah, most of you probably already know it, but in case you don't, let me copy it and paste it also in the chat here so that you can easily have it. Let me paste it here. Okay, several times. ROS2 run teleop twist keyboard, okay? You can use this command in order to move the robot using the keys of your keyboard, yeah? So basically, if you execute this program and now you are going to be able to use these keys indicated here in order to teleoperate the robot. Yeah, let me show it to you very quickly. For instance, let me move it forward. See, in the simulation, you can see how the robot is starting to move forward, right? And then if I stop it now, you're going to see how the camera is changing, right? So let me move it here. Let me rotate the robot now to the left so that I face this area here, and then you are going to be able to see also in the in RVs how the camera images are updated real time, right? Let me switch here. Okay, so right now what the camera is seeing is this area here. Yeah? All right, so now we have seen that the robot is working, we can teleoperate it, and we can also visualize the images captured by the robot's camera, okay? Then at this point, we are going to already start creating the service code, okay? This is going to be very guided, okay? I'm going to provide you a template. You are going to see in a moment, and we are going to review the code together. But the very first thing that we need to do is to create a ROS2 package, okay? So for this, let's, first of all, we need to go inside the ROS2 workspace, specifically inside the source folder of the ROS2 workspace. This is achieved with this first command here. So let me come here to the, let's come here to the terminal. We can already stop RVs if you want. Let's stop RVs to save some resources. And then here, we are going to cd into the ROS2 workspace src folder. Very important to be inside here. And then second, we are going to execute this command to create a new package, okay? Again, I recommend that you copy these commands directly from the notebook and paste them directly into the shell in order to make things faster, okay? So let's create our new package with the command, and then now you are going to see that inside this, the ROS2 workspace, you have this new package, botbox utils, okay? Now, at this point, my recommendation is that we open the code editor, okay? You can open the code editor very easily, again, by clicking on the icon that is next to the web shell icon. Yeah, it's this one here. You're going to see that it's titled code editor, yeah? If you click here, it's going to open the code editor, as you can see here, where you are going to basically have access to all the files, folders, workspaces, everything inside this project, but with a graphical interface, which is always much more convenient to work with for developers, right? Then here, for instance, we can go inside the ROS2 workspace, okay? src folder, and here we are going to find the botbox utils package that we have just created, yeah? Let me have a quick look at the chat here to see if you guys are following. Okay. Yeah? Are you guys following? Yes. Yes, yes. Yes, code editor, exactly. My robot don't move, says Marcus Albano. Okay, that is very likely that is because you don't have the focus in your keyboard teleop program, okay? When you use this teleop to his keyboard program, you need to have the focus in the terminal. Okay? What does this mean? This means that if you run the program, but your focus is somewhere else, your robot is not going to move, okay? Even though you press the keys, yeah? For the robot to move, you need to have the focus in the terminal, okay? So you should see the prompt here in your shell blinking, okay? This means that the focus is in this shell right now, okay? Let me stop this. It didn't move on Gazebo, so try this, okay? Try this. Very likely this is the problem, and still, if you don't see the robot moving, another possible issue is that your Gazebo client is not working properly, okay? Then just try restarting the simulation as I explained it earlier, okay? It could also be that your Gazebo client is freezed or something like this. All right, then let's continue, okay? So now we have created our package, right? Then the next step is to create our program, yeah? So what I'm going to do now is to create the Python file, which I am providing a template here, okay? Then inside our package, let's go inside the BotBox utils folder, and here we are going to create a new Python file, yeah? Oh, very easy. You just have to right-click here and select new file, all right? And then here you can select the name of the file, which is going to be picture_saver.py. There we go. Okay? And then here, what we are going to do is to copy and paste the code here from the notebook. Okay? Yeah? So this is a full template for the code, okay? I'm going to explain right now what is this, okay? But first of all, let's all of us create the Python file and paste the template code for the service server, okay? Hello, hello, hello. Can you hear me? I see someone said that I lost audio. Yes. Okay, okay. Okay, okay. Okay. Yeah. Then let's have a quick look here at this code, okay? So first of all, we are importing some libraries, okay? As in basically in any ROS2 program, okay? So I'm not going to go into super detail about everything because otherwise we would be without time, okay? So let me just show the most important parts of the code, okay? First of all, here, this line here is where we are creating the service server, yeah? And the name for our service is save image, and the interface that we are going to use is trigger, which is one of the default ones provided by ROS2, okay? And also here we can see the callback associated to our service, yeah? So whenever somebody sends a request, calls our service, this callback function is going to be executed, okay? Very important also to initiate a bridge for OpenCV, okay, so that we can better manipulate images. Here we are basically setting a QoS profile, and then also here we are creating a subscriber, okay? We are subscribing, of course, to the topic where the images of the camera are being published, yeah, the ones that we checked a moment ago in RViz2, so we need, of course, to subscribe to this information, yeah? Then down here, what we are doing is to define a new folder where we are going to save all the images, okay? Here inside the callback function of our subscriber, yeah, the subscriber for the camera topic, of course, has a callback function associated, and then inside this callback, what we are doing is to save the images that the camera captures into this latest underscore image variable, okay? So every new image that that the camera captures, we are going to save it into this latest image variable, yeah? So in this variable, we are always going to have the latest image captured by the camera, yeah? And then here we have the callback function for the service, okay? This is the most important part, actually, of our program, yeah? Because here is where we are going to put the logic for our service server, okay? So whenever our service is called, is sent a request, this callback is going to be triggered, okay? Then basically here what we are doing is, first of all, we are checking if there is an image, okay? In case there is not any image detected, then of course we are going to cancel the service, yeah, and say that no image received, okay? So first of all, we need to make sure that the camera is capturing images, okay? So we check this using this latest image variable that I was commenting a moment ago, yeah? And then here, I have a try section where you should do today's work, okay? And what do you need to do here? Well, this to do is explained with more detail down here. One second. Yeah. So what do you need to do here? Basically, two things, yeah? First of all, you need to convert the image message so that it can be used by OpenCV using the bridge, and then save the image received using the emWrite method, okay? You have an example code here, yeah? So as you can see, we are saving the image into this CV image, okay? Yeah? So what this line does is it converts the image from ROS format to OpenCV format, yeah, and it stores the image in this CV image variable, okay? And then here I am defining a file name, okay? And then I am saving the image with emWrite using this file name, okay? Yeah? Okay, so at this point, what I'm going to do is something, okay? I'm going to upload here my solution. Let me do it right now. Upload files, which I have here in the desktop. If I'm not wrong, yeah. Let me upload this, okay. So, okay, give me just 1 second. Box, star, 2 files, and then okay, there we go. Okay. Sorry, I was just getting this. Okay. Then here I have my code completed, okay, which I'm going to use and show it to you so that you can have a look also here. Okay, but I basically want you to complete this yourselves, okay? So I have not provided you the final code with everything working, okay? Now, notice, okay, well, yeah, let's go step by step, okay? So as you can see here, the try is completed, yeah? So what are we doing here inside the try? Well, we have this line, which is already shown in the notebook, yeah? We are converting the image from ROS format to CV format and saving it into the CV image folder. We define the file name variable, okay, to provide a name to each image saved, based also on an image counter. Then we do the image write, emWrite, in order to save the file into the folder. And then also here what we do is to fill in the response of the service, yeah? So in case the emWrite goes correctly, we set the success variable to true and we set up a message for our response, yeah? If not, if there is some problem here, then we set the success value to false, and the message we indicate that something has failed while saving the image, yeah? And okay, so this is all that you need to do in your code, okay, which is basically explained also here in the notebook, okay? Okay, the only missing part here is the part where I fill in the response of the service, okay, which is also important. Yeah, so right now you can start already working on your code. Yeah, so what should be then the final result of this? Okay, let's have a look. Let me already remove let me remove this other folder, rm-rf files, and then, okay, there we go. Okay. Important also, before compiling, to update your setup.py, okay? For this also I have provided the code here. So you can copy directly the code from the notebook and paste it into your setup.file. All right, I'm going to do this right now. And at this point, I am already prepared to build my program, yeah? So let me do this. Let me go to the root of the workspace here and then colcon build. All right. Second. All right. Okay, so this has finished building. Then let me now source. There we go. Then execute the service node with this command here, ROS to run, botbox utils, and the name of the node. There we go. And now in the third terminal, I can verify that the service is in fact running with a ROS to service list, for instance. And I should see my service here, save image. There you go. Yeah. And now, in order to test it, we can use the following command, which is also provided here in the notebook. Yeah. ROS to service, let me paste it, ROS to service call name of the service, which is save image, and then the interface used, which is trigger. Yeah. So what should happen when I send a request to my save image service? What should happen is that my save image callback here is going to be executed, right? Triggering all the process inside here and saving the latest image captured by the camera into a folder named it is botbox images, okay, which should be generated here, okay. Then let's test it. Let me call the service. There we go. There we go. Successfully, image saved successfully. And now if I go back here to my code editor, I can see that a new folder has appeared here, botbox images, right? And if I double click here in this image, I'm going to see the latest image captured by the camera, right? Which it is exactly the one that the robot is looking right now, yeah? We can see that now it's looking this process one area, and it is exactly what I'm getting, right? If I, for instance, move the robot a little bit, let me do it again with the keyboard teleop. Let me move the robot, I don't know, maybe I'm going to rotate it a little bit so that it looks to the entry, okay? Let me rotate it so that it looks to the entry here. Let me do that. Oh, it looks like my Gazebo client is bugged now, also, actually. Because the robot is not moving. Yeah, it looks like it's bugged. Okay, so let me call the service and see what is the latest image. Yeah, so it has rotated a little bit, as you can see. Yeah, to the left. However, yeah, for some reason, Gazebo client is not working, yeah. So actually what we can do, well, actually what I wanted to show is this, so not so important anymore, but just to show how to fix this problem, in case it happens to you also, all you have to do is to stop the simulation, okay? Execute this kill Gazebo script with the command that is shown, that I showed earlier, okay? And then relaunch the simulation. This should fix any problem with Gazebo, all right? There we go, okay? So now we can run again the service if we want, and then now what we should see is this, this wall here in front, yeah? So let's test it just to verify that everything is working as expected. And let's get our image, which is going to be this one. See, so now it's looking at the front wall. Okay? Yeah? Have you been able to reproduce this? Let me know here in the chat, please. Created the file in the correct place. When I paste the code into the editor, shows 57 errors with this file. Ian, don't use copy code button, but select the code. Yes, exactly, Ian. But so instead of using for the code, oops, sorry. So for the code, as Gilbert is saying, for the code pieces, instead of copying it with this button, I recommend selecting the code and copying manually, okay? Because otherwise, sometimes there is some strange characters are introduced during this copy-paste phase, okay? So yeah, that's a very good advice, Gilbert. All right, guys, so let me know. Have you been able to get some images with the service already? Yes, no? Somebody has been able to do it? Still copying the files, says Freddy. Okay. Then, meanwhile you are working on this, what I'm going to do is to show you this in the real robot. Okay? So I'm going to connect here to the real robot. Actually, I think I'm going to fall short in time. So let me do something real quick. Yeah, let me do something here real quick, which is to book the next slot. Okay. Now I can go back. I can go back to my ROSJECT. Okay. Because yeah, in simulation, everything is fine, everything is cool, but actually we want to see the real robot in action, right? So let's do this, okay? Then let me stop already the simulation here from my side. Going to stop it. And I'm going to switch to the simulated environment, okay? Then let me connect here to the robot. Okay, there we go. Yeah, so what I'm doing right now basically is to connect to the BotBox Real Lab, okay? So there we go, okay? You can see here the Real Lab, which I have here in a room next to me. Again, we can see there my colleague Lilin passing by, okay? And there we got, my camera stopped, okay. And there we have a little robot that we are using right now as substitute of the BotBox, okay? This is not the one which is delivered It's not this one, the ones that we have actually in the box, which are these ones, okay? This is one that we are using now to substitute these ones because actually we don't have any more left currently, okay? So all the ones that we had, they have already been sold. So we don't have any of these ones left. So then I am using another one here, which is very similar, okay? Then let me go here with the camera. Let me open the camera again so that we can see our little guy here. And then what I'm going to do now is to, first of all, let me check that I am properly connected to the robot. Let me run a ROS2 topic list here. Okay. And let me run the teleoptwist program to verify that I can indeed control the real robot, okay? So let me try to move it a little bit here. There we go. Okay, so yeah, as you can see, from the terminal, I can control the real robot here in the environment, okay? Excellent. Then let me stop here. And now it's time to test the program, okay? But for working with the real robot, I need to have a couple of things into account, okay? Let me move here to the notebook again. And down here, there is a small section which says real robot, okay? So what do I need to take in mind when working with the real robot? Well, first of all, the topic used in the real robot is not going to be image raw, yeah? So if I do a ROS2 topic list here with the real robot, I'm going to see that I have this image raw, but I have also this image raw compressed, okay? So for the real robot, I'm going to be using the compressed image, okay? Because I am connected remotely to the real robot, I would need to pass these images over the internet, over the Wi-Fi network, and that would be too much, okay? Because images are very heavy messages, yeah? So because of this, we are going to be using the compressed images, which are much better when working and when having to send them through a Wi-Fi network, okay? So what does this mean? Let me go back to my code. Well, first of all, it means that instead of subscribing to the camera image raw, let me comment out these lines. There we go. And let me uncomment these ones, yeah? There we go. And update this, yeah? So instead of the image raw, what I'm going to be connecting to is image raw compressed, okay? So I change the topic subscriber for this topic, image raw compressed, okay? Yeah, first change with respect to the simulation code. Now there is another change, another thing that we need to bear in mind, yeah? So the compressed image topic is actually a different message type than the image raw. So you'll need to subscribe to the type compressed image instead of image, okay? This is already taken into account here, yeah? So instead of the image message, we are using the compressed image message, yeah? Now, because of the different type, because now we are using this compressed image, you'll need to convert the image to a numpy array and then use the em decode method, yeah? In order to save the image as an OpenCV image, yeah? So if you remember, here in the service callback, yeah, instead of using this image message to CV2, now this doesn't work because we are working with a compressed image. So actually, I'm going to comment out this part here. And instead, what we are going to use are these two lines of code, yeah, which are provided also here, so that you can use them when you test with the real robot, yeah? Yeah, so we create an numpy array here, and then we use the image decode method from CV2, okay? Yeah? So let's recompile our program now that we have made these changes. Qualcomm build. Let me recompile my program with the new changes for the real robot. Now, source. Now I need to run the program, which is ROS to run botbox utils, and then the node is picture saver node. There we go. And then let me test this out. Now the robot is looking in that direction. So let me get the command here from the notebook because I don't remember it. There we go. So let me try my service. Okay, image saved successfully as botbox images, botbox image 1. Okay, so let me go to my code editor and check. And yeah, so in fact, we can see now that the robot is able to capture the images of the real environment. Yeah, let me actually move the robot a bit. ROS to run teleop twist keyboard and teleop twist keyboard. Okay, let me move it to look into those QR cubes, for instance. I'm going to put it facing here to see if we can capture them. Okay. Wait, the camera is refreshing. There we go. So I need to... Oh, this is going too fast. Let me reduce the speed. There we go. Okay. There we go. Okay, so here I have the cubes, which I wanted to face. Then let me stop here. Okay, and let me call the service here. Let's see what we get. Okay, we have the botbox image 2. Then let's have a look at the botbox image 2. And yeah, so we can see the cubes, and here we have our colleague also from the construct who is having a look at the robot. So yeah, as you can see, with very little changes, we can adapt the code from the simulation to the real robot. And this is great for educational purposes. For instance, here we are teaching how to create a ROS2 service, how to create topic subscribers, etc. Okay. So let me go back here to the... All right. So who wants to try this out? Now is the moment of truth. Has somebody been able to have it working in the simulation, first of all? Anybody? What video? Hello, hello. Okay. Okay, hello. Something happened here. You should be hearing me again, right? Can you hear me? Can you confirm? Yes. Okay, so I don't know if you heard me, but I was asking that now it's your turn, okay? I have shown you how to do it in simulation, how to get it done also with a real robot. So now it's your turn. Then first of all, has anybody been able to have it working in the simulation? To take the pictures in the simulation, in the Gazebo simulation? Anybody? You can let me know here in the chat. I'm building my simulation, says Paul. I am only watching, says Gilbert. I'm still working on it. Freddy? Okay. Okay, and somebody would be brave enough to come here to the stage and test it. Test it with us. I can provide you the code even if you want, okay? For the simulation or for the real robot, okay? All right, so I will give you some minutes, some final minutes to test it out, okay? A couple of people were building their code, so let's see. And even if it's not working, if you want, you can come here with me and we can try to test it together, okay? Let me, I'm going to move down here with you to see for one moment. Okay. Okay. Any results? Anybody? Let me check here. Will, I see you moving around there. Do you want to come here to the stage with us? What do you say? No thanks. Ashutosh, do you want to come to the stage? Are you working with the ROSJECT? If you are working with the ROSJECT, even though if it's not finishing, we can figure it out together, okay? But I would like to have at least somebody connecting to the real robot and try it out, trying the code there. Freddy, what about Freddy? Hey, we have Freddy there. Awesome. Okay, I'm going to give you the spotlight, Freddy.
So oh no, okay.
I can hear you, but the others cannot hear you. Okay, right now?
Oh.
Hello, Freddy. So let me give you a spotlight so that, 1 second. Let me see if I remember how to do this. Where are you, Freddy? Okay, hello,
all
Freddy.
Right. Hello.
Hello. Now the others should be able to hear you. Can you hear Freddy, guys?
Hi, everybody.
Yep. Okay. So now we both have the like a microphone and we can talk to everybody. Okay. So Freddy, have you been working with the simulation or?
Yeah, I opened the ROS project, the ROSJECT. Yeah.
Okay. So
yeah.
Do you have? Can you try sharing your screen?
Let's see.
You should have an option down besides your camera.
Yeah, I see it. Believe.
Let's try that.
Yeah, this should
Screen share, it's called. Okay, yeah, we can see your screen. Okay. Then have you tried the code in simulation or not yet?
Not yet. I was about to do the setup thing over here.
Okay. Yeah,
Yeah,
there it is.
read the section. But yeah, I guess some help would be appreciated.
Yeah, so here what you have to do is to basically copy that piece of code, the setup.py
Oh,
first.
this one.
Yeah, you need to select it like this. Yeah, select the code and then Control C or right click copy, whatever you want, and then paste the code here. Yes, exactly, into the code editor. That's it. Okay. Now open the botbox utils folder to have a look at your code there in the code editor. Yeah. Yeah, open this program. Okay. So this is what you have. Okay. Okay, let's try it out. So now, okay, yeah. Now what you can do is what you should do is to compile, basically. So you have the commands also down there. cd ROS to workspace and call build.
Oh, I see.
Yeah, you can copy paste this. This is just to compile your program and generate an executable node from it.
Okay.
Call build. Yeah. And then when it finishes building, it's the source. And then the next command is to basically start up your service. Okay, and then meanwhile, I'm going to prepare something so that you can connect to the real robot.
Okay.
Okay, source. And now you can execute the last command to start up your service. Okay. Okay, so it's running without any errors. Then what do you have in the other terminals, Freddy? In 3 and 2?
Believe this one to tell you up
Okay, and here,
script.
nothing. Okay, so
This one's
here, for
just
instance, type ROS to service list, just to make sure that the service appears there.
like service list.
Yes,
Like
exactly.
so.
Yeah. So here we should see a service which is called save image somewhere. Yeah, I can see it there. Yeah. Okay, then now let's try executing here, for instance, the command that appears in the notebook, this ROS to service call. Yeah. Copy this one and try, yeah. Okay.
Oh,
What it says?
it has no attribute message.
I'm going to zoom a little bit. False message. Success false message. Camera server object has no attribute MSG. Okay, can you show me your code, Freddy?
Yep.
Again. Are you using MSG variable somewhere?
Mm,
I don't see it. MSG in the callback, but that is correct. I don't see. Yeah, I think it's that. Yeah, wait. I think it's line 73. Do you see self MSG?
Oh,
Yeah,
yeah.
that doesn't look right.
Is
It
it
should be, let me have a look. I think that is not correct. That should be, wait a second. Let me check it. Okay, for some reason, I can't see anything here. Okay, there we go. Picture saver, it should be, Yeah, it's latest image.
Latest image.
Yeah, exactly. Because, wait, let me verify. Yeah, exactly. It's latest image because it is the variable that you are using in the topic subscriber. Right? Yeah. So in line 62 of your code, you see, you have, yeah. So you should use that variable. Because this is the variable where the latest image is stored. Okay? Yeah. This looks better. Then let's try it now. Let's try it now. And if not, I'm going to just share with you this part of the program. Yeah, so let's try rebuilding. Code build. We need to recompile because we have modified the code. Then this error will be gone at least, but I don't know if maybe there's going to be another. So let's try. Yeah, source, do the source. Yeah, there we go. And then ROS to run to start your service. Okay. And then, yeah, from the other terminal, let's call it. Let's try to call it. I think it was from the second one. From here, yeah. Let's try to call it again. What is that? Let me have a look.
Camera server has no attribute image.
Has no attribute image. Okay, let me have a look at your code again. Okay, I need you to scroll down a little bit your code. There, yeah. It's the image counter. It's line 79. So that is not correct because there is no variable image. Instead, it should be, it's
Like the image counter, like that.
yes, it's an underscore, right? Image underscore counter.
Yeah.
Yeah, that is correct, yeah. Let's try one more time, yeah, recompile.
Whoops.
Okay, it's okay, it's okay. I think it's, well, yeah.
That's supposed to source it first, right?
Yeah, it's more safe if you source, always, but. All right. Yeah, let's call it again. Okay. Okay. Okay, the folder has been created in your code editor. Can you see it? So let's go there and see if we have something. It's right below ROS to workspace, yeah. Okay, there is an image. Let's open it and see what you get. Okay.
Nice.
Okay, so we have it in simulation, but now I want to try it. I want you to try it with a real robot. So I'm going to send you a private message. Let me find you here. Freddy. Okay. Let me send you a private message. I'm going to share with you a link. Okay. Let me share it with you here. Okay, so you can stop the simulation now and everything here if you want in your current project.
How do I do that? Just like close the windows?
Well, Control C. Just go to the terminal and Control C. Yeah, Control C everything.
Whoops.
Yeah, don't worry, it's okay. Okay, so okay, actually, let me try something. what is your username in the platform? It is Freddy, something like this?
I believe it's Redmin, F-R-E-D, yeah, F-R-E-D-M-I-N.
Let me try to find you very quickly. Fredmin.
Mm-hmm.
Okay, so let me try to do something very quickly. 18 user. Okay, this one. Okay, can you try refreshing your project page? Fredmin? Just refreshing this page, yeah. The whole page. Okay, so in the bottom right section, you can see a red dot, right? Okay, so once the project finishes loading, this should allow you to connect to the real robot, okay? So wait a few seconds until this loading screen goes away. And now you can, so go there to that icon and press, you have to click on this turn on off part. You can see it. Yeah, there, exactly. Okay. Ooh. So this is, you are right now connecting to the real lab based here in Barcelona. Okay. I don't know, where are you based right now?
Salt Lake City, Utah.
Okay. So right now you are connecting to the robot that we have here in Barcelona, this bot box setup. Okay, there you have the camera. Okay.
Okay.
So now, before actually trying it out, let's go to your code. Okay. And then the very first thing that you need to do is to change basically what I did. Yeah. So you need to comment these lines from 43 to 45. You can comment them or you can remove them directly if you want, or comment them, whatever you prefer. Yeah. And then uncomment 47 to 50, which are the ones that are using, first of all, the image compressed topic, and also the compressed image interface instead of the regular image. Okay, and then you have to go down to line 74. Okay, comment line 74 there. And instead of this, you need to get the 2 lines provided in the notebook. Okay, they are provided in the real robot section. Let's look for them. There is a small section titled real robot. Almost here. So you need to copy these 2 lines, yeah, and paste them there, right below. Yeah, exactly. Yeah, indentation. Okay, now open a terminal again. When you connect to the real robot, all the terminals are restarted automatically for security reasons. So yeah, now we go to the ROS to workspace, we compile, we build the code.
Oh, I forgot these commands.
It's down. You're looking for the Qualcomm build section,
right?
right?
Oh, there you go.
Right there.
Yeah.
Okay. Yep. Okay, that is correct. Now let's open another terminal with the plus icon there, yeah? And then try calling the service. See what happens. Okay. Okay. Let's have a look at the folder. Okay.
Ah,
Okay, so let's do one more test. Freddy, let's try running the ROS2 run teleop twist so that you can move a little bit the robot and face point it to another place. Okay, yeah. It's not in the notebook, so let me spell it to you. It's ROS2 space run space teleop, and here you should be able to double tap for auto completion. Tap tap to W and tap twist
keyboard.
underscore teleop. Teleop twist. Ah, no, keyboard. Yeah. Teleop twist keyboard. Exactly. Yeah. And then again, double tap. There you go. Okay. Yeah. So now execute it. First of all, don't move it yet. Press the Z key.
What is that for?
The Z. This is for reducing the speeds.
Oh, I see.
Because otherwise you are going to start moving it and it's going to go too fast. Okay, so let's bring the camera so that we can see the robot. I mean the camera for the lab. It's the icon which looks like an antenna to the right. Yeah, this one. Okay, so here we have the camera. Then, yeah, so try moving it a little bit. Okay.
Try moving it right.
Okay. Yeah.
Oh, it just keeps going.
Yeah. In order to stop it, you have to press the key. The key. Okay.
The key.
K. Sorry.
Yeah.
Okay.
That's
Key.
fine.
Yeah.
All right, there you go.
There you go. Yeah.
Oh, this is fine. Okay, let's try moving forward. Whoops.
Okay.
Stop.
There you go. Okay, just in time. Okay, let's try it here, for instance. Let's try to take a picture because you should see the wall very close now.
Right. Okay.
Should be image 2. Yeah, so indeed.
Nice.
There it is. All right, so, okay, so great. Thanks a lot, Freddy, for being brave enough to come here up the stage with me. Now to, by the way, to disconnect, you just have to go again to the icon, the real robot icon there, and press again that, and that is going to disconnect you. Okay.
Okay. Awesome.
All right.
Well, thank you. This was fun.
Yeah. Thanks to you for coming here. I see that and also you were very fast and you got everything super quick. So it was very smooth.
Thanks, everybody.
Okay, come on, guys. Let's put some claps here in the chat for Freddy. Yeah. Yeah, there we go. Clap. Okay. All right, so I can see Maria here. Maria Akram, I would love to have more people, but unfortunately we are already 1 hour and a half into it. So I'm going to leave it here. In fact, this room is going to be closed in 5 minutes. Okay, it's programmed to be closed in 5 minutes at 7:30 CET. So yeah, I need to finish the class here. Thanks a lot to all of you. I hope that you have enjoyed this format. It's been a lot of fun for me, for sure. I think it's pretty interesting, and I hope that you can repeat something. We can repeat something like this in more open classes, because this basically enables interaction. Okay, and yeah, I think it's a great way in which we can connect to people who is also interested and who loves this field of robotics. Okay, so yeah, one last time, thanks a lot. Thanks for supporting the open classes during all these years. Actually, it's been already many years of open classes. Yeah, I don't know how many, but we have been doing these open classes for many years, and I'm sure that we are going to continue doing them in more years to come. So thanks everybody for supporting this. See you in the next one. And yeah, so now let's already leave this room. Let's go to the main lobby, and you can stay there in the lobby if you want and chat with other people and whatever you want, okay? So I'm going to go there also.